Hello students. In the last lecture, we have started the chapter Dual Nature of Radiation and Matter. And we had seen the photoelectric effect. Just recall the definition of it. The phenomenon of emission of electrons by certain substance or metal when it is exposed to radiations of suitable frequencies is called as photoelectric effect, and emitted electrons are called photoelectrons. With this, the experimental setup for the same we have studied. Okay, now let's see observations from the experiment on the photoelectric effect. As we have discussed already that in this experimental setup we will use the commutator key. By using, we can maintain emitter plate E at desired positive or negative potential with respect to the collector plate C. That means by using this commutator key, we can change the polarity between the two plates E and C. Initially, by using this commutator key, a suitable positive potential is applied to collector plate C. As already we had discussed in experimental setup to observe the photoelectric effect. And now you can see the same in this diagram. The positive potential is to be applied. See, positive potential by this commutator key is now connected to the collector plate, and the negative potential is to be applied by using this connection to the emitter plate. Okay. Now we will study the variation in photoelectric current. The photoelectric current is nothing but the flow of current due to photoelectrons which are emitted from the emitter plate E. So, we will see the variation in the photoelectric current with frequency of incident radiation, with intensity of incident radiation, next potential difference between the plate C and E, and the nature of the material of the plate that is to be used, which is our emitter plate E. So now it is make the point for all the observations that it is to be taken from experiments on the photoelectric effect. The very first observation is the effect of frequency on photoelectric current. Over here, to see this effect, first of all, a suitable positive potential is applied to the collector plate C. As already we had seen in this diagram that the positive potential is applied to the plate C there. Okay, so we are keeping constant a suitable positive potential that must be applied to the collector plate. Then the next thing is the intensity which is to be used for incident the radiation on the emitter plate E. That much intensity is kept constant. And then next over here we have to change the frequency of incident radiation there. So the frequency of incident radiation is gradually increased from its minimum value. Okay, now it is to be observed that there is no photoelectric current is recorded till a certain frequency nu 0 is reached. As you can see in this graph, which is to be plotted to observe the photoelectric current, and the variation in the photoelectric current we have to take on the y-axis, and this change in current that is to be observed due to the change in frequency, so it is to be kept on the x-axis. Over here in this graph it is very clear that on the x-axis there is a certain frequency nu 0 is written, below which you can see there is no value of the photoelectric current is observed. Okay, here the value of the photoelectric current is to be obtained when the frequency of the incident radiation reached this particular frequency nu 0. After that, as the frequency increases, photoelectric current is also increases. So the frequency is the characteristic of the material of the emitter plate E, and hence this particular frequency nu 0 is called as the threshold frequency. So we can define the minimum frequency of incident radiation for which the photoelectrons are just emitted from the photosensitive material is called threshold frequency. And over here, as I told you before, the emitter plate E is to be changed there. Okay, by using the different materials, the same experiment has been performed, and it was observed that this threshold frequency is different for different materials of the emitter plate E. And hence here we can say that the threshold frequency, as it is different for the different material of the emitter plate E, and below the threshold frequency there will be no emission of the photoelectrons takes place, and hence there will be no photoelectric current flowing in a circuit. That means, see in the definition also here the term suitable frequency was given. Just recall again, the phenomenon of emission of electrons by certain substance or metal when it is exposed to radiations of suitable frequencies is called photoelectric effect. So that suitable frequency is nothing but this threshold frequency, below which there is no emission of the photoelectrons takes place. To have the photoelectric effect, the incident radiation must have the frequency equal to or greater than this threshold frequency, and the wavelength corresponding to this threshold frequency is called threshold wavelength. This is the first observation that has been taken from the experiment on photoelectric effect. Now next, let us see the effect of intensity on photoelectric current there. To observe this effect over here, first of all, whatever the suitable positive potential is applied to the plate C, that is to be kept constant. It will be as it is. Okay. As now we come to know that to have the photoelectric effect, the frequency of incident radiation must be equal to or greater than threshold frequency. Okay. So for whatever the emitter plate we are using, okay, the threshold frequency value is to be known for each and every plate. So we have to kept the value of the frequency of incident radiation greater than the threshold frequency of that material used, and that much value of the frequency is kept constant. In simple words, the frequency of incident radiation must be keeping constant, and that value of frequency should be greater than threshold frequency, so that the photoelectric effect will be observed. Photoelectric current is to be flowing in a circuit. Over here we are observing the effect of intensity on the photoelectric current. That means how much intensity we should give to the emitter plate so that the photoelectric current is to be flowing in a circuit. And to observe this effect, here we are keeping constant positive potential that must be applied to collector plate. Next, the frequency of incident radiation we are keeping constant, that must be greater than threshold frequency. Now over here we have to increase the intensity of the incident radiation from the very low value. For example, you can take from the 0 value of the intensity, you have to start to observe this effect, as we are changing the intensity of the incident radiation so that it will be given on the x-axis, and observation we are making on the photoelectric current, so it is to be given on y-axis. So this graph will give the variation in the photoelectric current when the intensity of incident radiation is to be changed. Now from the graph it is very clear that when the intensity of the incident radiation is 0, photoelectric current is also 0. As intensity of incident radiation is increases by a very little amount, so for that the photoelectric current is also increases by means of the little amount. Next, as we are increasing the intensity of incident radiation linearly, the photoelectric current is also increases linearly. That means it is found that photoelectric current increases linearly with the intensity of incident radiation. So we can say that the photoelectric current is directly proportional to the number of photoelectrons emitted per second. Don't get confused. Here, the number of photoelectrons emitted per second is nothing but the photoelectric current. Okay, so as this number of photoelectrons emitted per second is directly proportional to the photoelectric current, so we can say that this implies that the number of photoelectrons emitted per second is directly proportional to the intensity of incident radiation. So this is the effect of intensity we had seen on the photoelectric current. 2 observations we have completed by using the experiment. Let us move further. The third is effect of potential difference on photoelectric current. Over here, to study this effect, first of all, we have to keep threshold frequency, that must be, and intensity of incident radiation, both are kept constant. That means the frequency of incident radiation we are choosing, it must be equal to or greater than threshold frequency. That value we are keeping constant, and whatever will be the intensity of incident radiation we are choosing, that intensity we have to take constant. By keeping these two value of frequency and intensity keeping constant, as well as the positive potential of plate C, which is to be initially given a suitable value. Okay, now what we are doing, this positive potential of the plate C we are gradually increases. As it is to be observed that as we are increasing the positive potential of the plate C, that is of the collector plate, the resulting photoelectric current is to be measured each time. That means as we are increasing the potential, every and each time, here we are noting the photoelectric current also. Here it is to be found that the maximum value of the photoelectric current will appear, which is said to be a saturation current. So now let us see about this saturation current. So first of all, over here, as the threshold frequency and the intensity of incident radiation both are kept constant at suitable value, the positive potential of plate C is gradually increases and it will measure the resulting photoelectric current each time. Fine. Now it is found that the photoelectric current increases with increase in positive potential. As you can see in this graph, here the photoelectric current we are representing by means of the y-axis. On the positive x-axis, here we are talking when the plate C is to be made positive. Here in this experimental setup, we are increasing this positive potential, okay, and each time we are recording the photoelectric current. So it is to be observed that as initially we are increasing the positive potential, you can see the current is also increases. Okay, that means over here, as we are increasing the positive potential, photoelectric current is also increases. But at some stage, for a certain positive plate C, that is of collector plate, all the emitted electrons are collected by the collector. Okay, here you have to remember that the plate C is made positive with respect to the emitter plate. From the emitter plate, the electrons are emitted, which are negatively charged particles, and being the plate C is at the positive potential, so that the emitted electrons would be attracted towards the plate C, and hence the photoelectric current is to be flowing in a circuit. But here you can see at certain stage for this, as you can see for the intensity I01, at a certain value of the positive potential, here all the emitted electrons are get attracted towards the plate C, and hence the photoelectric current becomes maximum. After that, if we increase the positive potential, as we increase the positive potential further of plate C, the current will be constant. Okay, that means the photoelectric current is not increases, and this maximum value of the photoelectric current is called as saturation current. Okay, so we are getting this saturation current because all the emitted electrons are collected by the plate C, that is the collector plate. Now, in the graph, you can see the different value of the intensities have been taken, and hence the photoelectric current is to be observed there. Okay, so let us see the next observation for the accelerating voltage and incident frequency when we are keeping it fixed there. Okay, for this purpose, over here we have to observe that intensity of incident radiation was increased and the value of the saturation current is also increased there. Okay, now here you can observe that as for the positive potential of plate C, a particular value of intensity and frequency we are keeping constant. For that, the nature we have got, the saturation current is to be observed there. Okay, next here you can observe that by keeping another value of the incident intensity, for example the second intensity we are increasing than the previous one. Okay, and the same experiment is to be repeated for this incident intensity, which is to be keeping constant, and the threshold frequency, the value we have chosen, that is also to be keeping constant. So the nature of the graph we are getting same. That means for the some value of the positive potential, photoelectric current is increases, and after that we are getting the saturation current, that is the maximum value of the photoelectric current. Okay, so here we can say that by keeping the accelerating voltage and incident frequency fixed, if the intensity of the incident radiation was increased, okay, the value of the saturation current is also going to be increased. The nature we are getting same, but the value of the saturation current for the first intensity is less than the value of the saturation current of the second intensity that we have chosen and keeping fixed there. Okay, that means the value of the saturation current is also increased proportionality. For example, if we are increasing the intensity in such a way that we are making the intensity double, the saturation current is also doubled there. Okay, from the graph itself it is very clear that the nature of the graph we are getting same. For the positive potential of the collector plate, over here the photoelectric current increases with increase in the potential, positive potential, and after some stage for the certain positive potential of plate C, all the emitted electrons are attracted towards the plate C, and hence we are getting the maximum value of the photoelectric current, which is said to be the saturation current. Okay, but the another thing you can observe here, that as we are increasing the intensity from the value 1 to 2 to 3, the value of the saturation current is also increases in proportionality. So here we have discussed the observations from the experiment on the photoelectric effect for the variation in the photoelectric current with frequency of incident radiation, where we are keeping intensity constant and suitable positive potential to the plate C is kept constant. Next we had seen the variation in the photoelectric current, where we are keeping intensity, we are changing intensity of incident radiation by keeping the value of incident frequency constant, and whatever the positive potential is to be given to the collector plate, it is to be kept constant. And in the variation in the photoelectric current, when the potential difference between the plates C and E is to be applied, where first we have considered the positive potential is to be given to the collector plate, and there here we have got, as the intensity increases, the value of the saturation current is also increases proportionality. Okay, so these observations we had made when the collector plate is to be placed at the positive potential with respect to the emitter plate. Okay, as I told you, by means of the commutator key we can change the polarity of the plates there. So now let us see the effect of the potential difference on the photoelectric current when the plate C is now made negative with respect to the emitter plate. Here we are now going to use the commutator key there. Students, please make sure that the variation in photoelectric current we are studying here with frequency of incident radiation, second, intensity of incident radiation, third, potential difference between the emitter plate and collector plate, and fourth, nature of the material of the emitter plate E. So, when we see the effect of frequency, other things we have to keep constant, and we have to change the value of frequency here to study, to see the effect of frequency on the photoelectric current. And to do so, we had seen the concept of the threshold frequency, and to have the photoelectric effect, the incident radiation must have the frequency equal to or greater than the threshold frequency. Next, when we study the effect of intensity of incident radiation, so here we have to change the value of the intensity from its lower value by keeping other things constant. And here we come to know that the intensity of incident radiation is directly proportional to the frequency, the photoelectric current there. Then next, to study the effect of potential difference between the emitter plate E and collector plate C, here we have to keep frequency, intensity and nature of the material kept constant. Then, as potential difference between the two plates, we are going to change here. So first, positive potential is to be given to the plate C, and you have to observe the record over there, and here we come to know that the photoelectric current will be increases till a particular value of the positive potential, and after that we are reaching the saturation current. Okay, then in the next part we have to change the polarity between the plate C and plate E, and over here we have to make the negative potential on the plate C and change the potential difference to observe the effect of this potential difference on the photoelectric current. Okay, and then next, to study the nature of the material of the emitter plate E, we have to keep other all things constant there and change the value or change the nature of material of the emitter plate E. That means by taking another material and by following the same observations, here we come to know that more about the photoelectric current, the variation in the photoelectric current with the particular emitter plate used there. So over here, the part of the potential difference between the emitter plate and collector plate with the positive potential for the collector plate C applied we had seen, and the next here we are going to use the commutator key by using which we can make the collector plate at the negative potential there. And inshallah, the remaining observations from the experiments on photoelectric effect we will see next time in the next lecture. Thank you.